Thank you for having me here. Excited to be here. This is a link to some of the workshop code that we'll be using if people want to follow along. If you don't, that's fine as well. I'll voice over most things. So it's a bit of a choose your own adventure. My name's Harrison. I'm the co-founder and CEO of LangChain. I'll do a little intro about myself while people pull up the materials if they want. So my background's in ML Ops. I've been working on LangChain for the past 2.5 years. We build developer tools to help make it as easy as possible to build applications on top of LLMs. So we think LLMs are great, but we think they're even better when they're combined with your own data and your own APIs and things like that. And so we build a bunch of developer tools to help with that. One of the developer tools that we build is LangGraph. So LangGraph is an orchestration framework for building agent and multi-agent systems. It's very low level. It's extremely customizable. LangGraph is extremely low level, is extremely customizable. So there's no hidden prompts. There's no hidden kind of like cognitive architectures. We don't enforce anything at all, really. And so this is kind of like a follow-up to LangChain. It's been out for about a year. We've seen pretty good adoption of it, including by other companies speaking at this event, like Replit, which was talking earlier. So they have their Replit agent, which is built on top of LangGraph and LangSmith. And so this is where we are encouraging people to start if they're thinking about building agent or multi-agent systems. One of the more advanced things that we're starting to see some people do with these systems is build in the concept of memory. So the idea of memory is if you interact with a human, they remember things about you. They remember things about previous interactions. And so it's not like having the same conversation over and over again. You don't have to constantly remind them of things. And because LLMs are so human-like in a lot of regards, I feel like sometimes we expect them to be the same way. But that doesn't happen. That doesn't just happen. You have to build that into the system. And so this is still one of the more researching advanced topics out there, but we see a ton of interest in it. And so actually today, we released with deep learning a course on agentic memory with LangGraph. And so that's what I want to cover today. So I'll start by just walking through some slides and talking about the different types of memory that we see. And we've mapped them onto human memory, which may or may not be the right thing to do. Again, it's incredibly early on in this whole space, but especially in the memory space. But I think it's a nice way to think about memory. So I'll talk about those. And then I'll walk through an example in code, and you can follow along if you want, of building an email assistant that has these different types of memory in it. So should be fun. Let's get started. So to help motivate some of this, we ran this survey a few months ago, asking a bunch of developers where they thought agents could have the most impact. One of the top picked ones was basically personal assistance and productivity tasks. So that motivates an email assistant that we will kind of like walk through building today. And this is actually one thing I've been building for the past year and I have running on my emails. So this is all of this is grounded in kind of like real use cases that I've built and used. And so the idea here is that the agent will be relatively simple. It will be connected to an email inbox. An email will come in. The agent, powered by an LLM, will use a variety of tools, such as a calendar tool to look at a calendar, to schedule calendar events, and then an email writing tool to respond to the emails. And so this is kind of like the basic setup of the agent. And if you think about how you would interact with an agent like this, it's similar to how you might interact with an EA if you have one. So they might ask you what types of emails you want to respond to versus ignore versus you should get notified about. They might ask you your preferences of when you want to schedule meetings. They might ask you your preferences for your tone. And these are accumulated over time as they do things and ask questions and as you respond and give them feedback and change things. And so there's all these questions throughout this process that, yes, you could bake in at the start through prompting. But one thing that we've noticed is that no one's really a great prompter yet. And even when I was writing the prompt for my email assistant, there are so many edge cases of different emails that come in that I could just not have predicted ahead of time. And so this idea of learning and adapting over time through feedback, I think is really important towards bringing the email assistant from bringing something that's like 80% useful to like 95, 97, getting it up there. And so the idea of adding in memory to applications is to really help them to maintain context over time, to adapt to our preferences, and learn from these past interactions. So what are some different types of memory? And so these are all grounded in different human types of memory. The first one is called semantic memory. This is typically referred to as just facts that you might remember. So the human example is things that you might learn in school, like specific dates, specific locations, things like that. Another type is episodic. These are experiences that you remember. So if you have a vivid experience of something that happened a week ago or a month ago or a year ago, that would be a type of episodic memory. So it's a specific, concrete experience, not a fact, but a concrete experience. And then procedural are instructions. And so these are instincts or motor skills, like riding a bike. That's a type of memory that we have. So how do we map these onto agents? So when we think about agents and when we think about semantic memory, this is pretty naturally represented as facts about a user. I think most people here may have heard of semantic search, so doing some sort of retrieval to select facts, that maps very naturally onto that. Episodic can be represented as past agent actions. So if people have heard of few-shot prompting, this is when you give an LLM examples of data points and how it should handle them, so inputs and expected outputs. And so this can be used to represent past agent actions and have this type of episodic memory. And then procedural are often just instructions. These are the system prompts that you give the agent. There's a supernatural corollary here. So these are kind of like the three types of memory that we see, what they look like in humans, and how they are applied to agents. One other concept that I want to talk about is how we update these memories. So we see two different strategies for how folks do this. One is in the hot path. And so what I mean by this is if you're interacting with an agentic system, it might update the memories before it responds to you. So in this kind of example, you see a user message, then you see a blue message which represents a tool call, so using a tool call to update memory, and then you respond to the user. And then same again. And so if you've played around with ChatGPT's memory feature, this is how it works under the hood. So it calls some memory functions to update it. It shows you in the UI that it remembered something, and then it continues to respond. That's in the hot path. A separate one is updating things in the background. So this is when you have a conversation that you don't actually think about updating memory in the moment, and then sometime later, there's some system that comes along and uses that conversation or those. I'm saying conversation because I think chat is the predominant UX, but by this I mean really like any interaction with an agent, regardless of the form factor. And so you take this conversation and you update the memory 30 minutes later or something like that. And that's what we call in the background. And there's pros and cons to both of these. And so in the hot path, you can show it to the user as it's happening. So it's kind of like user-friendly. And it applies right away, right? Like if it remembers something, that applies instantaneously. The downside of that is now your agent has to not only think about how to do its job, but also how to update its memory. And so you're giving it more things to think about, which can be a little bit tough for things to do. And then the other downside is that it can sometimes increase latency. And so if latency is super important, you might not want to do it that way. In contrast, in the background has the reverse effect. It doesn't introduce any latency, and you can have a completely different system that's responsible for this. The con of this is that it might not be super transparent to the user, and it might take a little bit for it to take effect. So these are some of the trade-offs. We'll actually use both of these in some of the courses. So how are we going to apply this to the email assistant? This is what we have. This is what we'll build. We'll first build an email assistant that will do a triage step. The triage step will basically be to filter out emails. So this is how I have my email assistant. There are emails that it should just ignore. There are emails that it should respond to. And then there are emails that it should notify me about. So it shouldn't respond to them, but it should notify me. So we'll use this to triage emails into 3 different categories. Then after that, if it's determined that it should respond to, we'll go on to the main agent where it has these tools, and it will loop. The agent will just do a simple tool calling loop, but you can make this more complicated. So where will we add in memories? First, we'll give that agent a separate memory tool. So we'll give it a memory tool for updating and for accessing semantic types of memories, so facts about the users that it's having a conversation with. Next, for the triage step, we'll give this episodic memory. So we'll give this few-shot examples. We found that few-shot example prompting is very helpful for classification tasks, and so this is a pretty natural, albeit simple, place to put this. And then third, we will have some of the system prompts of the agents, specifically some parts of the system prompt. So instructions for how to do meetings and the tone of the agent, as well as actually the triage instructions themselves. We'll have these be procedural memory system prompts that we update as well. So we'll be updating not the whole prompt, but the parts of the prompt that relate to these specific types of instruction. Cool. So this is an overview of what we will be covering. There will be 4 kind of like notebooks that we go through. The first one will just set up the email assistant. And so if you're not familiar with LangGraph, the first one will be an introduction to that. We'll cover some of the basic topics. Then from there, we'll spend 1 notebook on semantic memory, 1 notebook on episodic memory, and 1 notebook on procedural memory, all layering on top of each other. So you get 1 agent with all of them at the end. Before I jump into that, any questions? We'll maybe take 1 or 2 if there are any. If there aren't, that's fine. We can jump into the fun stuff as well. Yeah.
So I think this makes total sense, and I love it. And it really works if you're talking about an individual user. But if you were to expand this to some sort of enterprise setting, how do you deal with that memory management when business rules change all the time? One memory can conflict or impact another?
Yeah, good question. So the question was about how do you deal with this as an enterprise setting where you maybe have multiple users, things change over time, and there might be conflicts between memory. Great question. So there's a few things to think about. One, when we talk about all of these memories will be namespace to a certain collection. And so when we do this example, it will be namespace to the user that's using this email assistant. But you can namespace it to an organization, to a company, to the overall agent. So the agent itself could have its own memory. And so basically, you can split this memory whatever is most appropriate for the task at hand. So for example, if you have kind of like a SQL writing assistant, and there's a particular way of calculating ARR, that is not specific to a user, that's specific to the whole organization. And so you might want to remember that. So the namespacing and how you think about memories, that's one thing that's important. 2, for a lot of these, it's not just additive, it's also kind of like updating memories. So if something changes, the idea would be that it would update that memory. And so actually, this is like pretty easy to do for some of the procedural memory ones. It's a little bit harder to do for the few shot and semantic. So few shots are actually generally pretty additive. So you generally kind of accumulate these few shot examples. And then the semantic memory is tricky because when you have a new memory come in, you need to basically see what similar memories exist, and then if they should be updated or if you should add a new one to that. And so there actually is a bunch of nuance and trickiness there. And so in this course, we'll be using a package called LangMem, which contains a bunch of utilities. And so it contains utilities for when it's updating a semantic memory, you don't just like extract a fact. You actually first find like 5 relevant facts, put them into context, and then ask it to either update those facts based on ID or add a new one. And so there's some nuance there. And then to your third point around temporal kind of like memories, things that might go out of date, that's a really good point. To be honest, we don't cover that in this yet, and we don't have too many utils around that in the memory system. I think the way you would probably want to do that is build some type of, you'd want to make the store aware of time in some capacity. So if you have something like, this week I cannot take meetings, it recognizes that that only applies for this week. We don't have anything like that at the moment, but that's a great kind of like advanced topic.
Here.
I'll take these 2 and then we'll go on.
So I'm curious, what is the persistence layer for this kind of memory? So, for example, semantic memory, should it go to like a vector store as embeddings, procedural should go to a transaction store, episodic should go to a cache, like what is that?
Yeah, really good question about the persistence layer. So for those of you not familiar with LangGraph, there are actually 2 different types of persistence layer that we have baked in. The first one that we introduced is what we call a checkpointer. This is basically, you can think of this as a conversational thread. Now, for long-term memory, you want it to persist across threads. So we introduced a separate concept, which we call a store. This manages all three of those. The way it does that is it's actually quite simple. It's basically namespace key value store that supports semantic search. So for some of these, like the procedural ones and the episodic ones, actually episodic has some semanticness in as well, but for the system prompts, those are just stored as key value pairs, and they're namespaced by whatever you want them to be. So if you want them to be namespaced by the user, they're namespaced by the user. If it's by the org, it's by the org, and then inside the agent, you look it up according to that. The semantic memory and episodic memory, as part of the store needs to support semantic search, and so then you can enable that, and it will do semantic search over those examples. Last question before we go on.
So super quick. So actually I worked on something similar to this like a couple months ago. And one of the problems that I saw is like, if you have a high volume of emails, like token usage can pile up really fast. Do you have like, any tips on how to control the amount of tokens you're using there? I don't know, maybe you're only looking at the subjects, do you have any tips to not go super over budget?
Yeah, no, that's a really good point. I think if you think about this more generally, if you're running some system to do memory, you're basically using twice the amount of tokens because you're running everything through it again. The way that I handle this for my email assistant is I think actually a big part of this is designing the right interface so that you can. Because often when you want to update the memories, it comes through user feedback in some form. And so I think a lot of it goes into updating the UX in a particular way. What do I mean by that? I think if you can only put memory at certain parts, you want to make sure that you're putting it at really high leverage parts. So for example, in this email assistant, one of the things that isn't here in this simple example, but that I have in my real one, is if it doesn't know how to respond to a question, it will ask me. And then my response there, that's a super high leverage point to do these memory updates based on, right? Because it's the LLM is acknowledging that it doesn't have something in its current instructions or in its current kind of like semantic memory collection that allows it to handle it correctly. So that's a super high value place to put it. In this simple example, we actually do parts of that. The semantic memory, we don't take that into consideration, so it does, so this is where the in the loop stuff helps. So in the loop, you choose where to apply it. And so that's actually, maybe let me even back up. Like in the loop helps because the LLM is choosing where to apply memory updates. Thoughtful UXs help because you as the developer are choosing where to apply memory updates. So a lot of this is just choosing intelligently about where to apply memory updates so you don't incur kind of like twice the token cost. Cool. I'm going to go on to the first notebook just in the interest of time, but we'll have plenty of time for questions later. Cool. So I'm going to be using this if Wi-Fi permits. I will zoom in. This is the same exact stuff that is in the notebook. I'll try to run it. If stuff happens, I will just kind of like follow along in the code. So here we're just going to set up our email assistant. The first thing we're going to do is we're going to set up some of the prompt instructions and some of the profile information for our user. So we're going to provide some very basic information like name, full name, user profile, and then we're going to provide some prompt instructions. And so you can see that there's 4 different types of prompt instructions. So these are instructions for when to triage the email into the different categories. So for when to ignore emails, when to notify the user about emails, and when to respond. And then these agent instructions, these are for the main agent here once it gets here. So there's 4 different sets of kind of like instructions here. This is an example email that comes in just to see what it looks like. There's a from, there's a to, there's a subject, and there's a body. And so that's the shape of that. We're going to start by defining the first part of the agent, the triage step. We're going to import some things. Maybe the most interesting thing to talk about is this LangChain.chat models, importing it chat models. This is a nice interface that wraps all the language models in LangChain. So there's just a single endpoint, and then you can specify the model that you want here. So here we're going to be using 4L Mini, but you can use any model or any model provider that you want. We're going to be using structured output to help this agent respond in a way where we know what to do. So here we're going to define the structured output that we want from the model. As a reminder, the name of this, the description, the fields and their descriptions. These are super important. You should think about these as the prompts themselves. When building this, I would pay a bunch of attention to what you're putting here. Then this with structured output is a nice convenience method we have in LangChain where you can turn any model basically into a function that returns structured output. And so we're going to use that. We're going to pass in this Pydantic. We're going to pass in this Pydantic-based model there. We're going to import some prompts. So these are two prompts that are just strings. If we look at the system prompt for the triage step, we can see that there is this role information, some background, the basic instructions, and then the rules for how it should triage things. You'll notice that there are these things in curly brackets. So we're going to be formatting these with some of the things that we have up above. And then this is the system message. What we're also going to do is we're going to pass the email in. This is going to be passed in a user message. And it's basically just going to be, please determine how to handle the below email thread, and we're formatting it. So we're just using pretty simple strings to do the prompts here. We're not using any prompt classes or anything. We're going to format the system prompt. So we're passing in the variables in our profile, the variables in our prompt instructions. We're going to format the user prompt. We're passing in the variables in the email. And now we can just invoke it. So we're going to pass in a list of messages with one system message and the content being the system prompt, one user message, content being user prompt. And we should hopefully get back a response. I also have a version of this running locally, which may help if this. Let's interrupt it. There we go. All right. So we can see that we get back a response. And this matches the structured data that we asked for above. So we have a reasoning string, and then we have this classification field, and this was classified as respond. So this is doing the triage step. Let's now define the main agent. So we're going to import the something called tool. This just wraps functions and makes them available as tools to an LLM. So it wraps it nicely and then gives it like a name, a description, and makes it callable as well. And so we're just going to use this decorator to decorate some mock functions that we're going to use. So here, in real life, this would actually send the email, but here we're just going to mock out that it's sending an email. In a real life, this would actually schedule a meeting on a calendar. We're just going to mock it out. And then here we're going to mock out some availabilities that are just made up. OK, so we've got the tools mocked out. We're now going to define the agent. For this purpose, we're going to use a simple tool calling agent. So remember I said LangGraph was very low level. There are a few kind of like high level primitives that are exposed to make it easy to onboard. We're going to be using one of those here. And that's the simple kind of like tool calling agent. So there's a few things we're going to define. First, we're going to define a prompt. A prompt can be a string or a function. Here, we're going to make it a function. You'll notice that we're passing in this state object. I'll talk about that in a second. But the way that LangGraph works is you define a state of an agent. And then basically each node of the agent accumulates or adds to that state over time. So we're passing in this state. One of the things that's going to be in this state is a list of messages. These are basically the internal monologue of the agent as it's thinking about what to do, as it's calling the calendar tool, as it's calling other tools. And so what we're going to do is we're going to create the prompt by passing in the state. This prompt function should return a list of messages because this is going to be passed to the LLM. The first message here is going to be a system message. It's going to be using this agent system prompt, which again is, we've created in the background. We can see what it looks like if we want. I guess I haven't imported it yet. Let me print it out nicely. It's nothing too revolutionary. It's some basic kind of like role stuff. It says that we have access to these tools, and then it's the more instructions. These are taken from the instructions in the initial setup that I showed. We now have this function. It's going to have this system message plus all the messages in the state. Oh, there we go. I did it in the cell below anyways. Perfect. We're now going to import create React agent. This is the higher level agent that we're going to use. We're then going to define our list of tools. These are just the 3 that we have above. And now we're going to create React Agent. We're just going to pass in the string identifier for a model. We're going to pass in the list of tools and the prompt function, and we're going to get back this agent. We can now invoke this agent by passing in a state object. This state object, by default for this agent, is a dictionary with a messages key. So we're going to pass in a dictionary with a messages key. It's got one user message in it, which says, what is my availability for Tuesday? If we get back the response, we can see that it prints out, you have availability on Tuesday at the following times. These are the times that we hard-coded in the fake calendar tool. So let's now create the overall agent. So now we're going to be using more of the low-level LangGraph primitives. So the first thing we're going to do is define the state object. It's going to have the messages, and this is going to be the internal messages for the agent. It's also going to have the email input, which takes on the shape of the email that I showed at the beginning. It's just going to be typed as a dictionary for here, but you could type it more precisely if you wanted to. We're going to import some other commands. These are lower level primitives that are part of LangGraph for building agents. So state graph is basically the graph object itself. Start and end are the start and ends of the agents. And then command is something that we will use to jump from one node to the next. Here we're going to define one of the nodes of the graph. Nodes are nothing more than Python functions, so anything can be in them. It's going to take in the state as an input, and then we can see that it's returning a command where it's going to go to either the response agent or the end. So this is the triage step, remember? So what's going to happen is there's going to be some logic in here, and at the end it's going to output a command to either go to the response agent if it should respond to it, or to the end if it ignores or if it notifies. We're not actually going to handle notify that well in this example because it's not particularly important. The logic inside here. First thing we do, we're just unpacking the email a little bit. Next, we're formatting the system prompt. This is very similar to the logic I showed at the beginning. We're basically putting that logic that I ran through for the triage step into a node now. So we're formatting the system prompt, we're formatting the user prompt, we're calling the router. Now here is the logic for what we do with the results. So if it says respond, we're going to print out a nice little message just so we know what happened. We're going to have this go to response agent. So we're going to use this at the command down here. You'll see command takes 2 arguments. It takes a go-to argument. This is the name of the node to go to. And then it takes an update argument. This is the update to the state that we want to apply. So remember, we're passing around the state that we're updating. So here, when we respond, we're going to the response agent node, and we're updating with a user message that says respond to this email. If we're ignoring it, we're going to have no update to the state, so it can be none, and we're going to go to end, and then same with notify. In real life, it would do something, but here it's actually just going to be at the end. And so let's create that node, and now we put it all together. And so this is our final agent. It's pretty simple at this point because we have a sub-agent that has the tool calling agent, but we're basically going to create our agent by initializing the state graph with state. We're then going to add one node. This is the triage node. We're then going to add the other node, which is the tool calling agent, and we're going to call it response agent. So this string here is giving it a name. We're then going to add an edge from start to the triage router. And so this is basically saying the first thing we're going to do is hit the triage router, and then we're going to compile it, which basically just compiles the agent. We now have a nice built-in function in LangGraph to visualize the agent. So here you can see what it looks like. We start here. We go to the triage step. The response agent is this sub-agent here, which has itself a start and an end. It's pretty simple. It's got this agent node, which is just an LLM. It's got this tool node. The agent node decides whether to call a tool, so this is a conditional edge, or whether to end. And then the tool node always goes back to the agent. So it will basically loop until it decides to end. And here, so now let's try it out. This is an example email input. We can see that this looks pretty spammy. If we invoke it, we can see that we print out this nice classification of ignore. Here is another email input. If we invoke it, we can see that it requires a response. It's still running because now it's going to the main agent. And so now, let's print out the trajectory. And so one thing I'm actually going to do for the next lesson, I'm actually going to switch over to my local notebook where we have LangSmith running, which is our debugger, so I can show a little bit nicer what it looks like, but we'll just show it in the notebook for now. So here, we can see the trajectory. So first, we have this human message that comes in. It's basically like respond to this email. We then have the AI message. The AI message calls the right email tool, so it's calling the tool. The arguments it has is it's passing in the email to respond to, a subject, and then a content. We then see a tool message response. This is the response from the tool where it says, great, we sent this email. And then we see the response from our email assistant, which is saying, I've responded to Alice's email. This is the first lesson. This was just pure LangGraph, no memory involved yet. Any questions about this lesson, LangGraph concepts, before we move on to the fun stuff, adding in memory? Cool. All right, let's move on. I'm going to switch over to a local notebook now because I think it will be fun to show what's going on under the hood. And I think LangSmith will be good for that. So in this memory, we're going to add in semantic memory. We're going to do this by adding in tools to the agent. We're going to do this by using langmem, which is a package of these memory tools. So first, we're going to load some environment variables. This is all repeat from the last lesson, so nothing new here, nothing new here, nothing new here. All right. Now here is the tools for defining memory. So there was a question earlier about the persistence layer. The first thing we're going to do is import the persistence object. So we're going to use in-memory store. This is a really simple in-memory persistence layer. So in production, you would not want to use this. We have a Postgres, Mongo, and Redis implementations of this long-term memory store that you can use in production. But we're just going to use this because it's nice and easy. We're going to initialize it. When we initialize it, we're going to pass in a parameter for how we want to embed things. This will be used to embed the various things we want to use. So we're passing in OpenAI, text embedding 3 small. This is just the embedding model. All right. From langmem, we're now going to import two tools. One is a create manage memory tool, and the other is a create search memory tool. These are going to be used to create the 2 tools that we're going to use. One tool is going to be used to manage memory, aka update and add to memory, update, add, and delete from memory. And then the other is going to be used to create the search memory tool. And that's going to be used to search memory. You'll notice that when we create these tools, we pass in a namespace. So to the question earlier about how do you maintain things between users or between organizations, this is how you would do it. So you'll notice that we're passing in the same namespace for all of them. It's email assistant. It's a tuple. So there's different. It's a tuple of values. The first one's email assistant. The next one has this curly brackets LangGraph user ID. This is basically going to say that it's going to dynamically use the user ID that's passed in when we called the agent. So this means that we're going to have to invoke the agent a little bit differently from before. When we invoked it before, it was basically a stateless agent. It had no concept of persistence. Since we're now adding in persistence, we are also going to pass in some configuration. As part of that configuration, there's going to be this LangGraph user ID. It can be whatever you want. You want to change this to foo, you can change it to foo. I'll show you where to do that later on. And then we're also going to call it collection. I think I did this because for the next lessons, I think I'll use the same email assistant LangGraph user ID to start. But the important thing here is basically this is the logic that determines how these collections are stored. So these create tools. And so now if we look at like the manage memory tool, we have this tool, its name is manage memory. We have this description, create, update, or delete persistent memories to persist across conversations, include the memory ID when updating or deleting a memory, emit when creating a new memory, and then some instructions. You can change this as well, so you can pass in a custom description here if you want to give it different. This is basically prompting. So if you're finding this doesn't work, you'd want to change this. And then these are the arguments, and so we can see that the arguments have content, action, and then ID. So you can pass in content. That's basically the content of the memory. The action is then either create, update, or delete. And then the ID is the ID that should be passed in if you're updating or deleting. We can see the same thing for search tool. We have a search, we have a memory, and then we have the arguments. We've got 4 of them here: query, limit, offset, and filter. A lot of these have defaults. The one that doesn't is query. This will be doing a semantic search against the existing memories to find what works. We're now going to update the system prompt of our agent. So here now we're adding in 2 new tools that it has access to: manage memory and search memory. So we're telling it that has access to these. Other than that, it's exactly the same as before. We're now going to do the same thing as before. We're creating a prompt. We're creating this React agent. Our tool list now has 5 things in it. Okay, I hope I loaded my Anthropic API key because I switched. And you'll notice that when we pass this in, we now pass in store. This is passing in the persistence layer so that it knows to interact with it. Next, we're creating the configuration. So this is where I'll specify the LangGraph user ID. Let me zoom in a little bit just to make sure it's really clear. So here I'm going to pass in Lance as the LangGraph user ID. So everything that uses this, which is just now the memory tools, will use this user ID. So if I invoke it with a separate one, it won't know about the other ones. So here I invoke it with this content: Jim is my friend. This runs, hopefully. There we go. And if we print out the messages, this is the message trajectory. We can see the human message comes in: Jim is my friend. The AI message, the first thing it does is it calls this manage memory tool, and it calls it with this content: Jim is John Doe's friend. So John Doe is the name that we gave up here in the profile. We get the response that it created a memory with that ID, and then it's recorded. It says, I've recorded that Jim is your friend. All right, I'm going to open Langsmith because I think it will be cool to see what's going on under the hood. Here we go. Let me zoom in here. OK. So here, we can see a similar version of kind of like what's happening. Here we see the trajectory on the left. So we can see that we go into the agent node. But when we go into the agent node, the input is basically this list of messages along with this stuff. So this stuff we add in, and it's basically tracking the remaining steps. So steps are things that you can use to determine how long an agent runs. So there's some configuration there that is tracking. We see that we have this messages, and it outputs this AI message. We then call this tool. This tool manages the memory, and it calls it with this input. We get back this response. We then call the agent again. You get this input of human, AI, tool, and then the output is a new AI. If we want to see exactly what's going in to the prompt, this is where we can click into this LLM trace here. We can see all the functions and tools that it has available. So here are the manage and search tools. And so if we want to see the schema here, we can see the definition there. And then this is the system prompt. So you'll notice now there's no more curly brackets because it got formatted by the time it's going in here. So a lot of the time we see that these prompts are formatted by a bunch of variables that you accumulate over time. And so having this kind of like insight as to what exactly is going into the model is super important. If this is messing up, what you probably want to do is some prompt engineering. And so you can open it up in a playground here, get it access to here, change models, change the prompts, do everything there. Let's go back to the notebook. Now I can ask it, who is Jim? If we run it, we should see that it will call the search memory tool. So it calls it with the query Jim. We get back this response. You'll notice that this response from the tool message is pretty noisy. It contains a bunch of information. If we were doing this for real, we'd probably want to format that a little bit nicer and make it a little bit better formatted. And then we get back a response based on my search. I found that Jim is John Doe's friend. However, the imitation I have is quite limited. So great starts to add in other things. OK, so that's the basic usage of the tool. Now, if we want to see the actual memory itself, we can, because we can interact with the store. So we can list the namespaces that are available. We see here we have email assistant Lance, because this is the LangGraph user ID that was passed in, collection. We can search this. So search, you don't actually have to pass in a query. So here we're specifying the namespace to search against, but no query. So it's just going to return everything in there, up to some limit, I believe. And so you can see that we have this thing. This is a specific memory. This memory has a namespace that it's associated with, a key, which is the ID, content, Jim is John Doe's friends, a created at value, and an updated at value. And so and then a score as well. The score is none. If we search it with a query, now we will see that it has a score. So now we're doing cosine similarity and giving it a score and returning the ones with the highest value there. And I actually guess it does have some notion of temporalness, so when it was created and updated at, so it's possible you could actually use this to do some temporal stuff. Here, this is the same as before. We're just creating the rest of the agent, Let's now call it with an example email input and see what happens. So while this is running, I'll go back over to Langsmith. Let's see, I can see that this run is running. This is the one that I care about. So here we can see that it goes into the triage router. Just to show what this looks like under the hood, this is the prompt that gets created. So you can see that it's doing a bunch of formatting here. And then you can see that it makes this JSON response there. Let's reload and see if it finished. There we go. It finished. So we can see that the response agent, what does the response agent do? First, it goes to the agent node. The agent node calls a model. The model decides to write an email. It calls the write email tool. Goes to the agent node again. Previously, it just responded. But now, it decides to call. What does it decide to call? It decides to call the manage memory tool. If we go there. Oh. Well. If we go there, we can see that it wrote a new memory. So it wrote a memory. Alice Smith inquired about missing API documentation for authentication service endpoints. So we can see this as well if we print out the messages there. Now, if we have a follow-up email for the email assistant and it comes in and it says any update on my previous ask, if we run this, we should see that hopefully it responds to the email with knowledge of what happened previously. So here it's calling the search memory tool. Let me go back here because I think this is nicer. I think this is the most recent one. Yeah. Oh. There we go. So it calls it. We go in here. It searches the memory. It searches the memory for Alice Smith's previous request. It gets back this. We can see Alice Smith previously asked about missing API documentation. Again, you might want to format this a little bit nicer. It now writes an email. What email does it write? It writes an email. Hi, Alice. Thanks for following up. I'm still reviewing the API documentation for the authentication service, blah, blah, blah. So that shows how it can pull in and use previous information to make a response. That's it for this notebook, which is on semantic memory. Any questions about this one? Yeah.
So at least the episodic and the semantic memory seems like it can be done through RAG. So what is it? Are you creating data?
Yeah, good question. So the question was basically, it seems like semantic and episodic memory can both be done through RAG. And so what's different here? The main difference is that in this one in particular, so in this one, we're using an LLM to create the items that are in the database. So once it's in the database, it is basically RAG. We're not doing anything fancier than kind of like semantic search over it. The interesting thing about memory, in my mind, there's a bunch of things that are interesting. I think the trickiest part to get right about memory is probably using the LLM to extract or update or add this information. Like I think that's where, if it goes wrong, that's where it will go wrong. And so I think like that is actually one of the undervalued pieces, is like how can we get LLMs to reflect on these conversations and update things, either add memories or add instructions. This is a very simple example, right? But as you get more complex example, that's where a lot of the subtlety kind of like lies. And so I think a lot of the complexity of the memory systems will be around the using the LLMs to reflect and add to these knowledge. You could use a graph database as well if you wanted, but add to these knowledge bases, whatever these knowledge bases will be. For the episodic one, which we'll see in the next lesson, that's a little bit simpler, and that is basically just retrieval, and that's very similar to RAG. I think what makes RAG different from memory. So like memory definitely uses retrieval under the hood, but I would say like in my mind, if you're adding information to the database through user interactions, I would call that kind of like memory. Where if it's like a static kind of like, corpus, I would say like, sure, let's use retrieval, let's use RAG or something there. At least in my mind, that's how I think about it conceptually. Good question. Good question. Any other questions? Yeah.
Follow up on that. If Jim stopped being your friend, would it go to like simply a newer memory that trumps the older one, or would it replace it? Can you speak to that?
Let's see what happens. I think a lot of this comes down to prompting and what you tell it to do, but we can absolutely see what happens. So here, let's scroll up to here. So let's make sure that these still exist. Yeah, okay, so we can see that there's multiple memories. Yeah, sorry, the question was if Jim stopped being my friend, what would happen? And so here, let's try this. So I think what will happen, let's see what happens. Jim is no longer my friend. And okay, so interesting. Okay, so here we can see what happens is okay, so the human message comes in. The AI calls manage memory, and it creates a new memory. John's relationship with Jim has deteriorated. They're no longer friends. And then it says it's created this memory. So now, okay, so let's see. I've recorded this change in relationship status in the memory system. This will help me be more sensitive and appropriate in handling any future situations involving Jim. Would you like me to take any additional actions regarding the situation, such as adjusting any meetings or communications that might involve Jim? Let me check if there's any relevant scheduled interactions with Jim that we should be aware of. And so then it calls the search memory tool. And it searches it for meetings or appointments with Jim. And it gets back the existing ones. And we can see that one of them is Jim is John Doe's friend. And the key here is 439. And so we can see I'll update the previous memory about Jim to reflect this change, and it deletes this memory. So we can see that it calls the manage memory tool with action delete and this ID. And then if we now check the collection, we can see that, yeah, the one about Jim being the friend is gone, and we now have this relationship deteriorated in there. And so this is all done through prompting. Like and so this is where memory's just as finicky as any of the other kind of like LLM applications that you have. It might have forgotten to check. I actually think so in LangMem, one of the things that we have is a more complicated tool that when it tries to manage, and so this is a simpler tool because it's running in the loop. So this is running like in the hot path of the agent. And so typically you want to have simpler tools that the main agent can use. And so the arguments are pretty simple in there. One of the systems, I shouldn't say tools because we don't expose it as a tool, but one of the systems we have in LangMem is like a background processing thing that basically takes in a conversation and then tries to update memories. And as part of that, it will search for relevant memories before it tries to update them. And so I think that's probably a more proper way to handle things like that, and that's often why we prefer to do kind of like background processing of memories. But this was a funny and actually correct resolution, I would say, of it. So yeah. Any other questions? Yeah.
This is a trivial question. Is updating memory always in the form of insert and delete memory as you show, or is in place update?
Yeah, is update memory always insert or delete? There is an update as well. I'm guessing the reason it didn't call it here is because it actually added a memory before it realized that it should delete. Yeah, but there is an option to update memory. Yeah. Cool. Yeah.
What about multimodal memories?
Good question. What about multimodal memories? So right now, that's a good question. So the underlying store is it's just a key value store. Probably depends on the implementation. I imagine it would support that. It probably wouldn't support embedding out of the box. So I would imagine we would support kind of like key value lookups of multimodal memories, but not necessarily semantic search over those at the moment. Good question though. Yeah.
About embedded models, can I use whatever model I want, or do you have any kind of limitation?
Yeah, good question. You can use any model you want. So here, when we set it up, we specify a string. These map to a bunch of LangChain embedding models, but I believe you can also pass in a function where if you just want to provide a function, you can just do that. Yeah.
Yeah, in your background process, could you maybe use natural language inference like Roberta to check and see if that contradicts?
Yeah, you absolutely could. In the examples, the question was about the background process, and could you use natural language inference like Roberta to see if the memories conflict? You absolutely could. We just use an LLM to determine that, basically. So we find semantically the 10 most relevant memories to the conversation at hand, insert those, and then basically say, like, update these or delete these as needed. But you could have a different process. The one we've implemented, and maybe one like point about memory, similar to LangGraph, where LangGraph is very low level. We've tried to make our memory abstractions pretty low level as well. The LangMem stuff you see here is higher level. So I would think of, if you think about like LangGraph and LangGraph memory, I would think about like LangGraph lower level, and then like create React agent higher level. And then I'd think about like the store low level, and then like LangMem higher level. So we're using the higher level things here, so they are opinionated about what you can do, and the value of that is it makes it easy to get started. But we also like extremely recognize that it's very, very early on in this space, definitely for memory and even for agents. And so a lot of what we do is try to expose the lowest level things possible. So if you wanted to do that, you absolutely could in a LangGraph agent. We just don't have pre-builds for it. Well, maybe one more question and then I'll go on to the next one.
Does it have the ability to like search the web, and for example the email thing, can we do like Gmail can parse in real time and do stuff for
Yeah, so the question was, what abilities does this agent have? Can it search the web? Right now, we just gave it kind of like fake tools and pretty simple tools. But if you wanted to add more tools, it's pretty easy. You just pass them in this list when we create the agent down here. And these can even just be functions. So you don't even have to add the @tool decorator. You can just pass in a function. It will configure it as a tool for the agent to use. Yeah, good question. All right. I'm going to go on to the next lesson and then take some more questions after that. So lesson 4, oh, not that. Okay, so lesson 4, we're going to add an episodic memory. We're going to add it in at the start of the step when we're doing the triaging of the emails. The email step is just a classification step. We've found this to be a really good task for using few-shot prompting. So let's load in some stuff. Let's set up the profile, prompt instructions, nothing new. Okay, so now we're going to load in our in-memory store. This is the same as before, and we're going to give it this embedding model. We're now going to start embedding. So remember, this step does the triaging of emails. So for the few-shot prompts, we're basically going to want to have examples of previous emails and how they were classified. So here we can have this email. I was reviewing the API documentation, and we can create this data object. This data object now contains the email and the label, because remember, we're going to be fetching these, and we want to fetch not only the input, but also the output. So we're going to store that. And now we are going to store this in the store. We're going to store this with this namespace, email assistant Lance examples. So this is different from the previous one. The previous one, I think, was collection. So it's going to be different here. This is the UUID of the example that we're storing. And then the data is the data object here. So we're going to store that. We're going to do the same thing with the second example. Here, we can see that we get another email as part of this. If you see here, no immediate action items are needed from your side. So this label is actually going to be ignore. So we're going to store that there. We're going to store it in there. OK. So now we're going to write the code that will basically search and return these examples and then format them as well. So this is the formatting that we're going to do for these examples when they're passed into the LLM. And I'll show this in LangSmith to make it more clear. But we can see that there's this basic template here where we put in the email. And then we have the triage result, which is the result of the classification. When we format a bunch of these, what we're going to do is we're going to take in a bunch of examples. The examples are going to be things that we fetch from the memory store. The things that we stored in the memory store, remember, have this shape where they have an email key and a label key, and then the email key has this author to subject thing. So we're gonna do examples.value. This is just the shape that the memories have. Email subject. We're gonna put these in the examples, and then we're gonna come up, and then we're basically gonna concatenate these in a list. I'll show what this looks like at the end. Here we have, I think this is either the exact same email as before or a very similar one, just to make sure that the semantic search is working. So now we're calling store.search. We're passing in the collection here. The query is just going to be a string of the email data, and we're passing in limit equals 1, because we just want, this is just a sanity check to make sure that it's working. Now if we call the format few-shot examples one, this will print out the string that it fetches. And so here, and so this is the very similar email from before, and so we can see that it's fetched and it's working great. Now we're going to update the triage system prompt. So this is this is basically this is the kind of like episodic memory, adding it in. We're now going to, or this is the base of the episodic memory. We're now going to add it into the agent. We're going to add it into the triage step. That means we're going to update the triage prompt. Here you can see that we now add in this few-shot examples. And so you can see here are some examples of previous emails and how they should be handled. So we're updating that. And now we are going to do, this is all the same as before. This is all the same as before. And now, OK. So now this is the node itself. So we're going to get the email data. This is same as before. Now we're basically putting together everything we had above into this node. So we're going to create the namespace. The namespace we're going to get from the LangGraph user ID, which is passed in through the config. OK, great. We're going to create this namespace. We're going to search the store for this namespace with this query. We're going to get back these examples and call format few-shot examples to format them. And then we're going to pass these in to the new triage system prompt. And then we're going to call, and it's going to be the same as before. So that's the same as before. This is all the same as before. We're still going to have these manage memory tools. We're going to build it. Cool. And now just to kind of like see an example of this in action, the email input is going to be from Tom Jones. Quick question about API documentation. We're going to pass it in. We're going to pass in this config with the LangGraph user ID of Harrison. This is going to say, looks like it said respond. Yeah, so it's calling respond. Then what we're going to do, and just to show that this is working, we're going to add in an example to the store with this same kind of like example data point and with the label of ignore. And I'll come back because I want to talk about the UX around this, because I think this is a place where the UX plays a really important part. But let's just assume that we've gotten this kind of like correction somehow. We're going to store it there. Now we're going to call it, and hopefully it ignores. Yay, there we go. So this email can be safely ignored. We can see that it doesn't just handle the exact same emails. This is the whole power of LLMs. They can kind of like extrapolate and reason. And so here we can see that we invoke it, and it should ignore it. And if we try it with a different user ID, because it doesn't have this email in it, it will get a different kind of like response. So that's an example of adding some pretty simple kind of like episodic memory into the triage step. I want to talk about the UX around this, because you notice that the updating to the memory didn't happen kind of like automatically. It happened by me running this cell, which put the memory there. So one of the big things that we think about is UX for these applications. And the reason I think, and a lot of the importance of UX is about putting the human in the loop at the right steps. And I think human in the loop is really important for a few reasons. For 3 reasons to be precise. So one, it can help you just get better performance. So if we think about kind of like deep research by OpenAI, they ask you a bunch of follow-up questions before it actually writes the research report. And that helps yield kind of like better results. 2, it can help users gain confidence in the system. You can put human in the loop before it calls a dangerous tool, for example. So for my email assistant, I actually have to go in and approve every email that it sends. So it's like playing a video game. I press like approve or reject or something like that. But then 3 is that this human in the loop is where you can get user feedback and you can start to grow memory. So the way I have this hooked up in my email assistant is I basically have a UI, and we've open sourced this UI so you can see it. But I have a UI where when an email comes in and it drafts an email, if I don't want to respond to that email, there's just a little ignore button, and that clears it from the inbox, but then that also automatically creates this kind of like few-shot example. And so that it's really simple, but I think like having the actions in the UI where the user is interacting and giving things and hooking that back up so that it influences the system is like a subtle and kind of like underrated point. That's it for episodic. This is probably the simplest of all the memories to kind of like explain and reason about. But any questions about this or things that we've covered up to this point before we go on to the last lesson, which is my personal favorite. One back there, yeah.
Have you looked into memory chunking? So what's the appropriate size? Like let's say a large email with 10 different bullet points comes in. Is it better to split those up into 10 separate memories or keep it as one?
Yeah, good question. So the question was around memory chunking. Like if a large email comes in with like 10 separate bullet points, is it better to split those up or keep those as one? We haven't done too much there, specifically around memory. That's where I think kind of like the same kind of like ideas around retrieval would come into play. So I think like this is basically just RAG and retrieval. And so I think anything that applies there would definitely help. The other thing that I'd say, and this is foreshadowing what we'll look at a little bit more in the next lesson, but like rather than storing that raw email, you can also store a transformation of that email, usually done by an LLM or something. And so you can, one change that I actually want to make to my email assistant, the agent inbox that I have, is that when I click ignore, there's also an option for me to say why I ignored it. Because then it can start to incorporate that, and it can use that either as the triage thing, or as we'll see in the next lesson, to update kind of like the prompt itself. Oh, yeah.
I have a question on the retrieval as well. So let's say not for this example, but overarching enterprise example, right, where you have so many users with their emails and stuff. How do we ensure like the data is not proliferated between one agent and the other? If it's your email and private information, I should not be able to access it. With shared memory or things like that. So how do we control the privacy?
Yeah, so the questions around controlling the privacy of the different memories if you have multiple users within an enterprise. So 2 kind of like thoughts here. One, this is where the namespacing comes in handy. So you can namespace it to just this user, and then you put that behind some. And then part 2 is you let users use this behind some authentication. So obviously, if like I just had raw access to this, I could type in anyone's name and like see their memories. But like one of the things that we have in LangGraph platform, which is a platform for deploying agents, is a way to add custom authentication. So then basically you can only see the memories, the threads, everything that you're authenticated for. And so you'd basically put this authentication on different namespaces and say like Harrison only has access to namespace 1. Jim only has access to namespace 2. You'd pass in some authentication token, and that would get verified through whatever authentication app you have, and then that's how it would kind of be guarded that way.
So can agent do that, or you need to associate some kind of a tool with the agent for logic that's processing and figure out the session?
The way that it works is each session has its own session ID kind of like automatically, and you can pass in. The way that it would generally work is it heavily uses some of the previous kind of like, or it heavily uses just general authentication. Like you pass in some auth token, it verifies that. Once that happens, it will say like, okay, use this session ID, use this session ID, use this user ID, things like that. Any other questions? Thank you for the water.
I have a question. When you use episodic memory to sort of capture the experience, so like in the real world, if I go to a zoo, like what do I capture? And for example, you have an AI system. Once you start to capture, so you don't capture the whole conversation. Like, have you thought about this? Or do you have any guidance?
Yeah, that's a really good question. So like when you think about episodic memory, like what do you actually capture? If you go to a zoo and you have this whole experience, like what do you capture from that, and what is that, and how does that help guide? I think that's a really interesting question. I think the episodic, so the next type of memory we'll talk about is procedural memory, and that's like more instructions, and then we also have semantic memory, and those are more facts. So those are more kind of like fine-grained types of kind of like memory. Whereas episodic memory is just more like, here's something. And so the way to think about it is, I think like the procedural and semantic memory are more focused, but maybe lose some of the context. They're like a lossy representation of the whole thing, which can be good or bad. And I think a lot of like whether episodic memory or procedural memory will be better depends a lot, honestly, on some of the models that you're using. So some of the models that have smaller context windows, you almost always want to pass in like a representation of the memory, a condensed thing with extracted things, because it just can't handle the whole memory. Whereas if we get models with really long context windows and really good in-context learning, then maybe just passing in episodic memory will be enough, because during the forward pass of the model, it can just reason about this memory and be like, oh yeah, I went to the zoo and like, you know, I got splashed by you know, the whale, and I don't like whales because of that, or something like that. I think at the moment, like we generally see that few-shot examples are really good for classification and maybe some structured data extraction things. Whereas if you have more complicated instructions, it's generally better to distill that from a memory and just put that in the prompts. But again, as models get better and better, if they get better at this type of like in-context learning over large amounts of examples, that could start to change. This is like very easy compared to the other one. Like in the other one, we had all the prompting around the tool, like names and arguments and like what would it do, and there was a bunch of relying on like the prompts to do it. This is very easy by comparison, right? So there's kind of like pros and cons to both. Yeah. Last one, and then I'll go on.
Is there any way to handle like short-term versus long-term memory inspiration?
Yeah, any way to handle short-term versus long-term memory? Yes. So as part of LangGraph, we haven't covered it here, but there's two different types of like memory store. One memory store is just specific to that like thread or conversation. So if you think about it in a chatbot, that's just memory for just that conversation. This type of memory is across all conversations. There's another kind of like temporal aspect, which you mentioned, where maybe you want it across conversations, but only for the next week. This is something that we haven't explored as much yet. Cool. All right, I'm going to go on to the last one, and then we can round out with any final questions. So, great. Okay, so this is procedural memory. Procedural memory is basically instructions. This has a super clear mapping to agents, which is, it's the prompts, it's the instructions. This is also my favorite one, because I think a lot of people are thinking about things like prompt optimization. And I actually think memory and prompt optimization are two sides of the same coin, and I think this really shows it off. So here, this is the profile. These are the prompt instructions. We're going to be optimizing these and changing these. So this is going to be the focus of this lesson. This is all the same. 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 This is the same. This is the same. This is still the same. We've got our memory tools, all the same. Okay, so the first thing we're going to do is, in the previous lessons, when we created the prompt for the agent, Actually, did I skip one part that was important? Let me check. I did skip one part that was important. All right, this was not the same. I lied. We're going to go back here. Okay, so in the previous lesson, when we formatted the prompt, what we did was we formatted it with just the dictionary we had up front. We were using that as a global variable, and we were just passing that in. Now what we're going to do is we're going to store those values in the store and fetch them at runtime. And the reason we're doing this is so that we can change them later down the line. So here you can see that, so this is the same up to here. Then we start creating our namespace for these instructions. So the namespace for this is just going to be our LangGraph user ID, and then we're going to have one which has the key triage ignore. So this is going to be the specific instructions for when to ignore emails during the triage step. So we can see that we're going to look for this in the store. If it doesn't exist, we're going to put a default value in there. So this is basically saying the first time it runs, there's not going to be any memory of these instructions for what to do, so we're going to put a default value there, and we're going to use the generic prompt instructions that we had above. And then we're going to set the value that we're going to format into the prompt to be these prompt instructions. If it does exist, then we're going to get this value, and we're going to use this as our instructions. And then we're going to do the same for the triage notify, and the same for the triage respond. So we're going to do this in the main agent as well, and so I'll just skip down there. So here you can see we're doing the same thing with the agent instructions. We're basically moving it from this global variable to something we fetch at runtime. And again, the reason we do this is so that we can update it per user, per organization, per whatever. So we can update it, and then it can be used in the future. So that's kind of like the simple change. And then we're going to create the agent in the same way. OK. So this is an email that comes in. We can see that it will classify this as respond. If it's always scary running this because maybe something changed with the LLM or something like that, and so then the response might change. But here we can see that it classifies it as respond. We can see the current values of long-term memory. So there's 4 different parts of these prompts. These are the things that we have up there. And now we're going to use the LLM to update the instructions. So basically what we're going to do is we're going to simulate getting some feedback. So we're going to simulate getting some feedback as always sign your emails John Doe. And so we can see before that we signed it, I guess we already signed it John Doe. So we'll change it to be like best John Doe or something like that. And so then, again, this is where kind of like UX comes in handy because you want to get this feedback from somewhere. This can come, so in the agent inbox that I have, which maybe I'll show that off at the end if we have time, there's basically a spot where I can respond to the agent. And if it drafted an email, I can say something exactly like this: always sign your agent, or always sign your emails John Doe. So this is kind of like the data that we're going to be using to update the prompts. You can also think of this as one step in kind of like prompt optimization, basically. Again, I'm going to use this parallel because I think they go hand in hand. OK, so we've got these. Make sure I'm going to import this. I'll show what's going on under the hood with this. I think this gets traced to Langsmith, but this is a prompt optimizer that we have off the shelf in LangMem. OK, so import or define the conversations that we're going to use to optimize the prompts. Then we're going to define the prompts. So now there's 4 different prompts that we're passing in. Each of them has some information about them. So they each have their own name. So we're calling one main agent, we're calling one triage ignore, et cetera. Each of them has the current prompt value. So this we're going to get from the store to make sure it's the most up-to-date one. Then we're passing in instructions on when to update this prompt. That's because under the hood, what we're using is an LLM to determine when to update the prompt and how to update the prompts, and so we need to pass in instructions. So we have update instructions there's when to update and then update instructions, which are how to update this prompt once you've determined to update it. So here we can see that we want to update this prompt. Whenever there is feedback on how the agent should write emails or schedule events, we want to update the triage ignore prompt, update this prompt whenever there's feedback on which emails should be ignored, etc. The update instructions is pretty simple here. It's just keep instructions short and to the point. In real life, you would probably want to make this more specific to the prompts and the information that you're trying to update there. We're going to update the multi-prompt optimizer. There's a few different types of ones that we have. This is kind of like the simplest one, so we're going to use this. We're going to use Anthropic to optimize the prompt. Interestingly, we saw that Anthropic's Claude Sonnet models and the reasoning models by OpenAI were good at this. 4.0 and then other similar kind of like non-thinking models were actually not amazing at it. And then we're going to invoke the optimizer. The optimizer is itself a graph. So I'm going to go into LangSmith afterwards and show what's going on under the hood a little bit. But here we can see, this will take a little bit. Actually, yeah, I'll just go into LangSmith now and open it up. So here that we can see we're running multi-prompt optimizer. And here, yeah, okay. So one of the things that we're doing is we're asking so what's going on under the hood? First, we're asking an LLM to classify kind of like which prompts should be updated. And then once it determines which prompts should be updated, we're asking an LLM to actually update the prompt. So first we can see that we're saying analyze the following trajectories. The trajectories are the list of messages and decide, along with the feedback, and decide which prompts ought to be updated to improve the performance on future trajectories. And then we pass in the information here. And we can see that we get, we're responding with two different prompts that should be updated. The main agent prompt and the triage respond prompt. So the triage respond, probably because it's in the trajectory that it's decided to respond to the email. So it wants to make sure that it continues to respond to that email. And then the main agent, because that has to do with how it signs its emails. So we can see here we added in some reasoning about why. Based on the trajectory, there's two key issues to address. The main agent prompt needs updating because the email signature was incorrect. This was the main one. Then we can see that there is, we can see here in the, so this is updating the main agent prompt. So here you're helping an AI agent improve. You can do this by changing their system prompt. We pass in the current prompt. So this is where the current prompt gets passed in. It's very basic. You use these tools when appropriate to help manage Sean's task efficiently. Then we pass in, these are examples of various agent trajectories and associated feedback. So this can be using multiple examples, but it's just using one. And so we pass this into the prompt. And then we say, here are instructions for updating the agent's prompt. This is where we pass in the instructions that are specific to that prompt, because different prompts might want to be updated in different ways. And then based on this, return an updated prompt. And then we can see the response. We have some logic. And then we have the new prompt here. Use these tools when appropriate to manage John's tasks efficiently. When sending emails, always sign them with best John Doe. So this is kind of like the feedback that I passed in. And now this is part of the new prompt. So here, if we print out the updated prompts, they should be there. If we make it a little bit easier to read, we can see them there. And now we're going to update the prompts in the store. So here, we're going to loop through. And we can see that we updated, these are the two kind of like prompts that were updated. And so they're getting added now into the store. So we're using store.put with the previous ones. And now if we look at the agent instructions, we see that this updated prompt is there. And now if we re-invoke this, we should see that hopefully it signs off with best John Doe. Write an email, best John Doe. So it's incorporated that. As another example, if we get another email from Alice, we run it, we get this conversation, we now pass in feedback, ignore any emails from Alice Jones. If we run this, this is the same thing as before. We're just passing in instructions for when to update prompts and how to update prompts. We pass this into the optimizer. You can see that it updates the triage ignore, and now it basically it ignores that email. And if we look at the prompt, it now has part of the prompt, which is ignore all emails from Alice Jones. So the core idea here that I want to emphasize is, or there's a few key things. One, like at its core, this is using an LLM, or it's actually using an agent. It's using a LangGraph agent to update kind of like the prompts itself. A big part of that is using an LLM call to reflect on what's happened and used the examples of trajectories and associated feedback to update the prompt. If you think about prompt optimization, so prompt optimization, I mean running some eval loop where you have evals that are running over inputs. So you run an application over some inputs, you get back some outputs, you score them, and then you pass that into a system to update the prompt. That's very, very similar to this, right? You're passing in kind of like the outputs instead of the whole trajectories. You're passing in some automated feedback instead of user feedback, but the idea is the same. You're passing it to some LLM-based system, and you're using the LLM to update the prompt. And then another really important thing here is, the key thing here is setting up the UX so that you can get this feedback efficiently and effectively. Because without that, there's not going to be much useful things to update the prompt. And then the last thing I'd say as well is that a lot of this relies, again, on this LLM-based agent. And so we have a few different variants of this within LangMem. There's kind of like different techniques. You can pass them all to the same LLM call and ask it to just update all prompts in one go. You can do this thing here where we basically have a classification task where it classifies which ones need to be updated and then applies those updates. Sometimes these prompts get long, so one of the things that we actually use is we use this thing called trust call. This thing called trust call basically applies large JSON schema updates to things. So basically it generates a JSON patch instead of the whole new thing. So if you're working with a JSON object, then that might be useful. And then the last thing I'll mention is that one of the, right now we are just representing this prompt as a single string. If you start to accumulate a lot of memories here, it might be better to represent this as a list of prompt instructions and do some semantic search to find the relevant ones at runtime. Any questions about this one? Yeah.
So the first thing that came to mind when watching you was, okay, LLM hallucination. Over time, once you get one hallucination in there, doesn't this just throw this completely out the window and it's got something crazy in there that destroys performance?
Yeah, so the questions about LLMs hallucinate, won't kind of like one hallucination in there throw this off. Yes, in some sense, yes. So that's definitely kind of like a possibility. This is, in practice, I think, one, if it throws something off, as a user, I'll notice that if it starts signing everything as like from me as like, you know, Joe or something like that, I'll be like, no, you should sign it as Harrison. And so this is where, again, human in the loop matters so that you can correct it. And if it starts hallucinating, just like it can hallucinate responses, it can hallucinate memories. If it starts doing that, you can correct it in real time through natural language. The other thing you can do and I've done, is you can go in and see the memories that it's accumulated. And that's kind of actually fun because you can see like what it's learned about your tone and style, and then you can manually kind of like edit them. And so I believe ChatGPT does this as well for its memories that it extracts. It gives you a way to go in and see what they are. I think that's super important because yes, those can absolutely be hallucinated. And so having some kind of like transparency into what's driving it is really, really important. And then that's also where I'd say like having this type of observability here with Langsmith is really important, because if you're a developer who's debugging, hey, why did my agent just call someone the wrong name? You got to be able to go figure out why. Like where is it coming from in the prompt? Is it in the memory section? If it's in the memory section, which memory part messed up? Like which previous step caused this? So like I think you know, a lot of what we do is try to make these systems as reliable as possible. It's still not easy. If it was easy, you know, that would be great, but it's still not easy. But I think hopefully some of these tools will make it easier.
So
question on the observability. Is there a way for LangSmith to like publish all this to data and all and Splunk and this kind of?
Yeah, on the observability, is there a way to publish this to Datadog and Splunk? And yes, we have bulk exports, so you can export them to your own data warehouses, and then we also have some exports that you can set up to run them through OTel to some other systems as well, so you can plug them through. Yes, that would actually, so what we see people generally doing is more kind of like logging them to both places and then having a reference from one to the other, if that makes sense. So rather than flowing through LangSmith, you flow to LangSmith, so you can do the LLM observability. You also flow to Datadog or whatever, so you can do the system level observability, and they're linked, so if you want to go from one to the other, you can do that. Yes?
Is there any way to set up priorities for memories? Like accumulated bunch, and then which one applies first?
Yeah, good question. Is there any way to set up priorities for memory? So if you have conflicting things, which ones apply first? Not explicitly in this. If I was doing this, so there's a really good paper, or there was a really good paper 2 years ago out of Stanford called, I think, Generative Agents or something like that. And they basically set up a whole simulation of agents, and they spent a lot of time on memory. The way that their memory system worked was, one, there were some parts of their memory system that were the raw events, so there was the episodic memory. There were other parts of their memory system that were generated by LLMs as like reflections. For all of these, they had some importance score that they assigned to that, like during runtime, and then they also had a timestamp for when it was kind of like created. And then their retrieval mechanism was a combination of semantic similarity, the assigned importance score, and a temporal bit. This is generally more complex than we see being necessary, so we haven't implemented out of the box in LangMem. But I would, and the reason for that, and why is that more complex than necessary? Oftentimes we see people using memory for very specific tasks. It's not kind of like general purpose, kind of like AGI-like knowledge. So you can get away with simpler, more focused things. But I think that paper, I'm pretty sure it's called Generative Agents. I might be messing up the name. That's a really, really good one to go and look at for ideas around this. Yeah? Yes, what about vulnerabilities against injections? Good question. I mean, I think that's, to be honest, I think that's somewhat of an unsolved issue, not only for memory, but also for other things. I think a lot of the issues around, or a lot of the danger around prompt injection happens when you actually hook it up to tools that can do dangerous actions. Like I think it's one thing for you to trick an LLM to tell you a dirty joke in response. It's a whole other thing for you to trick an LLM to delete a database or something like that. So I think this is where human in the loop comes in handy, and designing these systems appropriately and giving tools the right scopes and things like that. I don't think there's an out-of-the-box kind of like solution for prompt injection things. I think it's really important that everyone's aware of it so they can design systems that kind of minimize the surface area that they can cause harm to. Yeah? Yeah. So this is hooked up to my real email, so hopefully there's nothing too bad. What is it? It's at... oh. Okay, so this is email inbox. I might show it off for our social media agent rather than email, just so I don't leak any thing. So this is basically we have a social media agent that's running. It's on a cron job. It looks for, or there's some parts of it that's on a cron job. There's some other parts that can be triggered manually. It looks for interesting things that people have built with LangChain. And then what we do is we often highlight a bunch of community stuff over the weekend, and so it lines up a bunch of these posts. And so here I can go in. And so here we can see that we have, let me zoom in. We can see a few things. So here, this is a bunch of details about the thing that it fetched. So we can see that there was this original kind of like tweet that it's pulling from. It's pulling from this Twitter here, talking about MCP. It links, it pulls out the relevant, this is all the agent, it pulls out the relevant links. It then writes kind of like a post. And then this is where I can interact with it. So this is, we've tried to optimize for different types of feedback that you can gather. So what exactly can I do? Okay, so there's two buttons up here. One's mark is resolved, and then the other is ignore. Mark is resolved will basically just close out this thread, and it won't actually update any memory, because I think sometimes there's cases where I just want to do that. Specifically for emails, if I've already responded to it in my email inbox, then like, great, like it might have been a good classification. I don't care about messing around with it. There's this ignore button. If I click this ignore button, what will happen is it will generate a few-shot example and store that in long-term memory that specifically that content like this we should just ignore. Like this isn't worthy of being shown. Next, we basically have the tool call that it's trying to do. So here we can see that it's trying to generate a post on this date with this post and with an associated image. So I can actually edit this directly. I can either accept this or I can kind of like edit this directly. If I edit this directly, what will happen is in the background, it will use an LLM and basically say, this was the original thing, this is the updated thing. Based on the change that happened, like what can you infer about the prompt instructions? And then the last thing you can do is you can actually respond to the assistant directly. So here I can give it natural language feedback. I can say like, use a ton of emojis. Let's send this. This will actually now run the graph in the background, so I can see it kind of like running. These are all the different steps of the post, so it's rewriting the post. If I go back up, wow, okay, a lot of emojis, right? So this applies to this post. What also happens is this kicks off another job. It actually kicks it off instantaneously, but it runs in a separate process in the background where it will update instructions based on this. So we'll look to see the current instructions. It will say, this was the post, this was the feedback, what can I apply? So this we've really tried to optimize for gathering a lot of feedback that can be used to update some of the assistants. I believe I'm all out of time. So thank you all, and happy to chat more about this later.